All right, so we are in geometry. Today's date is Thursday, September 19th. Please write it down. We are on 9/19/19. That's just 91919. Yeah, can someone tell us what our objective is today? Quiet raise hand, easy XP. Who has their card? Oh yeah, Jose.
All right, well, probably. Trying to find possible triangle side.
Gunner, you lost 10 HP. Stop talking while other people are talking. Go again, Jose.
Certain lengths are possible.
Thank you. All right, and Josie, you're in charge of giving XP, right? So did you get him his 50 XP? Where is it? Off task. All right, so we are dealing with the triangle inequality theorem. It's a notoriously hard theorem, but in practice, it's pretty easy as long as I gave you correct tools. And it looks like some of the lengths weren't quite right, which is kind of throwing us all for a loop. Can we just start shouting out things that worked for side 3? Shout them out.
4, 2, 3.
4, 3. Did 2 really work?
Yeah.
2 should not have worked.
Then how come it worked?
It's probably worked because of the bad sticks that I handed out. But 2 should not work. 2 should be over here. So if you have 2 on that side, please erase it. It should not be on the side that worked.
Wait, didn't you tell us that 2 worked? Yeah, you did tell us that 2 worked.
I did?
Yeah.
Okay, that's my bad. It should not have worked.
Teacher.
It is a teacher error.
Oh, that's cool.
Everyone's here today, right? I can give everyone the 70. All right. Shout out some things that worked for 5 and 4. Shout them out. What do you have? 4, 3, 2. Anything else? What are things that did not work? 1. 5 and 2. Things that worked.
4 and 5.
4 and 5. Anything else?
1.
Things that did not work.
1.
1. Anything else?
2.
2. Anything else? 3. Things that work for 2 and 3.
4.
Hopefully you found nothing.
Wait, 4 worked.
4. Oh, 4 works. Yeah, sorry.
Teacher again?
Teacher.
I'll give it to you guys.
To who though?
To all of you guys.
Oh, let's go. Wait, do we log it in our teacher?
No, not when I give it to everyone.
Okay.
4 does work. What are things that do not work? 1. 1 does not work. Anything else? Does 5 work? 5 also does not work. What about 1 and 2? What are things that worked and did not work? 1 did not work. Okay.
What?
1 did not work there. Look, if you have a 1, and a 2, they're the same length. It just makes a straight line. Think about it mathematically, not physically.
Yeah, I got it. No more physics.
Anything that worked for 1 and 2?
No.
Nothing worked for 1 and 2?
5.
5 did not work.
Yeah.
If you have something that's 5 and then something that's 1 and 2, that there's no way to make a triangle with those pieces.
Oh, 4.
What about 4? 3, so think about 3. If I have 1 and a 2 and a 3, they should be the exact same length. They should just make a straight line. That should not have worked. 3 should not have worked. I'm pretty sure everything did not work for this one. Gunner, you're treading the line. 3 and 4. Question.
So you use the same like you use it twice.
Yeah, people were borrowing from the left and the right.
So 1 and 2 works.
So 1 and 2, which one worked? You said 1 and 2 both worked?
No, just 2.
Oh, just 2. You're right. 2 does work. Uh, 3 and 4. What worked?
5.
Gunner.
1 did work.
5 does work, yes. Did 4 work?
Yeah.
Did 3 work?
Yeah.
Did 2 work?
I don't know about that one.
2 will also work there. Okay, obviously I will improve this lesson for future cases. I already have an improvement so that we don't have the same gunner complaint of it kind of works if you do it.
It works. It doesn't kind of work. It works.
So observations. So just looking at the table above, this is the hard part. This is the mathematical part. All we were doing was playing. Now we're doing the playing with numbers, playing with the mathematics, the patterns. What patterns do you notice about lengths that worked?
They didn't have one.
They didn't have a 1. Okay, so we can write it down if you want. Didn't have a 1. Any other observations? Okay, we can just leave it at that. What about patterns that did not work?
All ones did not work.
So all 1s didn't work.
For every pattern, one didn't work.
Okay, what's another observation? There's a lot of things that didn't work, like this 2 didn't work, for example. Why did the 2 not work? Why did the 3 not work? Why did the 5 not work? There's a bunch of things that are not 1s in this column. Why did those not work? Any ideas? How could we explain what's happening? All right, turn to a neighbor. See if your neighbor has any. All right, talk to me. Did anyone have any cool discussions? I heard a few. I'll call on you if I need to. Yeah, Fernando, do you have your card?
Yeah.
I'll take it. Yeah, what'd you find?
I found that if 2 sticks equaled one number, it didn't work.
Oh, so like the first 2 sticks that we had?
Yeah.
So for example, if I add like 1 and 2, then 3 won't work. And if I add 3 and 4, 7 won't work. I guess we don't have a 7. If we add 2 and 3, 5 won't work. If I add, I guess those are the only small numbers. So yeah, if you add those 2 sticks together, they won't work. Let's write it down. Add first 2 sticks. The sum doesn't work. So if you add the first 2 sticks in the first 2 columns, then their sum won't work. And that makes sense because if I have a length of 1 and a length of 2 and a length of 3, 1, 2, and 3, they should be the same length, so they can't make a triangle. It's just a straight line. Let's do the opposite operation. So Fernando said add them together. Add them together. Let's see what happens if we subtract them. For example, 5 minus 3. Oh, look at that, 2. Let's try subtracting. 5 minus 4. Oh, look, 1 doesn't work. Let's do 5 minus 2. Oh, look, 3 doesn't work. So that would be another pattern that we can find.
But not on all of them. 2 minus 3 is -1.
You'd have to do the vice versa, 3 minus 2, right?
Oh.
Take the bigger number minus the smaller number. Yeah, so if you always do bigger minus smaller, that subtraction problem doesn't work. So subtracting, I could say the difference. Difference doesn't work. And it's that same idea of eventually your triangle is going to turn into a flat line and it's no longer a triangle. So these are the main 2 observations that I need you guys to understand. If you add them together, the first 2 sticks together, it doesn't work, or anything bigger than that. For example, if I came back to my table and I added 1 plus 2, that was 3. If 3 didn't work, 4 is not going to work, 5 is not going to work, 6 is not going to work, 7 is not going to work. Anything bigger than the sum is not going to work. Vice versa, if I subtract them, for example, if I do 5 minus 2, that's 3. Anything smaller than subtraction will work. 5 minus 2 is 3. 3 doesn't work. 2 doesn't work. 1 doesn't work. Half doesn't work. A quarter doesn't work. Anything smaller than the subtraction doesn't work. Anything larger than the addition doesn't work. All right, give me a fist of 5 how well you think you can understand that idea. Being honest, 1. Give me honest answers. I see a 3, a 5, a 3, a 5, a 4, a 4, a 4, a 5, a 2, 3, and okay. 3.5? Okay. All right, hopefully I'll make it clear over time. But that's what we want to say. If we have two side lengths of a triangle and they're A and B, then if I add them together, I always have to be smaller. C always has to be less than what happens if I add together A and B. A plus B. So take your first two side lengths, your first two columns, add them together. I need to be less than that. So C needs to be less than the two things that are added together. But it also needs to be bigger than what? Is there a quiet raised hand that can do the other side? This has to be bigger than what? We did the plus sign. Next we're going to do the, is there a quiet raised hand that has a card? Anyone has a card? No one has a card? I can just take a normal hand then. Andres, is that your card? Yeah, I'll take it.
For XP?
For XP, yeah. Thank you, Joseph. Good. What goes on the left-hand side?
So it would be A minus B.
A minus B, there it is. A minus B, where we assume that A is the larger stick because we don't want to have a negative answer. So we'll make a note here. Assume A is bigger. You can also say that A is bigger than B, nice and quick like that. That is the one formula that you need to have down by today. I know that the lesson wasn't as big of a hit as I was hoping, but that's the idea. Subtract them, it has to be bigger than that. Add them, you have to be less than that. It's that simple. Let's try applying this to 4 problems. On the back. So that's a side length of x on the back on example 1. That means that x could be really small, it could be really big. I want to know all the possible sizes that x could be. For example, do you think that x could be 3?
No.
I think it could be 3. I think it could be 4.
But if you do 5 minus 3, it would have to be bigger.
Bigger than that. What's 5 minus 3?
28.
5 minus 3.
2.
2. What's bigger than 2?
Oh,
3,
okay,
4,
now,
5.
okay. Okay.
All right, so again, you're just using the formula. A minus B. Subtract the two numbers that you're given. Subtract the two numbers that you're given. Andres, 5 minus 3.
2.
2. I have to be bigger than 2. I'll use this in blue. Can someone do the right-hand side? What's the maximum that you can have? With a quiet raised hand. Just go off of the formula, guys, if you're struggling. Gunnar. 8. There it is. Add them. It has to be smaller than that. Subtract them. It has to be bigger than that. And think about that logically, too. It makes sense. I can't be bigger than 8 because if I have 3 and 5 and 8, 3, 5, and 8, that makes a straight line. 5 plus 3 has to be slightly bigger in order for that to work. Or 8 has to be slightly smaller for that to work. That's it. Let's try it again. Example number 2.
Wait, that's it?
That's it. That's all you have to do.
So you don't even have to get X?
You don't. That is x. X has to be. It's a certain range. X is between 2 and 8. So 3 would work. 3.5 would work. 4 would work. 5 would work. 6 would work. 7 would work. 7.5 would work. 8 would not work. 9 would not work. 1 also doesn't work for this one because 1 is outside that range. Let's try another one. Example number 2. What are the range of possible sizes for side x? Monse, do you have your card? You can raise your hand with your card. Yeah, go for it, Monse.
3 and 11.
There it is. 3 and 11. It's that easy. Thank you, Monse. And Josie, thank you for getting her XP. Done. That's how quick these problems are. Triangle inequality theorem. Subtract them, it has to be bigger. Add them, it has to be smaller. Let's go with example 3. Slightly different problem. So now I'm giving you 3 sides and asking you if it's possible. This one might seem confusing at first, but it's not that hard. The way to approach this problem is just pick any 2 sides. 3.2 and 6.7. And do the same process again. Ignore the 2.1. I could ignore any one of them. I could have ignored 3.2. Let's ignore 2.1 for now. Let's only look at 3.2 and 6.7. Do the same thing. Let's subtract them. 6.7 minus 3.2. Quiet raised hand. 6.7 minus 3.2. Fernando? 3.5. 3.5. Everyone write it down. I subtracted them. I'll put a little minus sign above it so you know that I subtracted it. And I'll put x here. to do the range, just like we had above. And then I'm going to add them together. Who can add them together with a quiet raised hand? Quiet raised hand. Who can add them? Andres.
9.9.
There it is, 9.9. That's what happens when we add them.
Wait, so that's it?
Well, it's almost there. So that means while we ignored 2.1, we only looked at these two. We know that with these two, your range of possible third sides has to be between 3.5 and 9.9. Now the question is 2.1 in between 3.5 and 9.9? So the answer is no. The answer here is no. Let's try it again. You guys do this by yourselves. Subtract random two sides, add random two sides to get a range, and then check that third side that you ignored. See if it's in that range. Go for it now. All right, quiet raised hand to walk us through the entire problem. All right, Andres.
So
Which two did you
first
pick?
I picked 1.5 and 6.3, so
Okay.
I subtracted 6.3 minus 1.5, and I got 4.8. And then after you do that, you add 6.3 and 1.5 and get 7.8. And then you check if the leftover number 5.1 is in between 4.8 and 7.8, and it is indeed in the middle of them. So yes.
There it is. Thank you. I will point out also that it is kind of hard to do 6.3 minus 1.5 because it requires you to borrow. But if you chose 6.3 and 5.1, that would have been a much easier choice because 6.3 minus 5.1, it's very easy to see that's 1.2. So if you're doing this, the strat is pick two numbers that's really easy to subtract. Adding is pretty easy. Pick the two easiest numbers to subtract. Yeah, but that worked. It was kind of harder, but we got the answer was yes. All right, give me a fist of 5. How well do you think you could do examples 1 through 4 on your own if I switched out the numbers? Fist of 5. Honest fist of 5. Let me go around the room. 5, 4, 4, 4, 3.5, 4, 4, 5, 4, 4s and 5s, 9s. All right.
No, 4.5.
Oh, all right. There it is. So don't do the summary. You can go on to Khan Academy. If you have questions, now is the time to ask.